Happy Industrial Water Week, everybody. Trace Blackmore here, the host of the Scaling Up H2O podcast, and we are smack dab in the middle of Industrial Water Week. It is Cooling Wednesday, and today we are celebrating everything cooling. Now, yesterday we celebrated boilers, and then on Monday we celebrated pre-treatment. And as you know, this is a very special week because not only is it Industrial Water Week, we are at the Association of Water Technologies Conference in Grand Rapids, Michigan. Yesterday, we had the business owners meeting. Today is the golf tournament. And then later today, we are welcoming new certified water technologists, new CWTs that recently achieved that amazing designation. That's taking place a little later tonight, and so many things to celebrate. And that's why we have a holiday that we have to have a week long to celebrate it, because there's so many wonderful things to celebrate in Industrial Water Week. And if you're here at the Association of Water Technologies Conference, it is my hope that I get to meet you this week. It's my hope that you and I get to talk. I want to hear what you think about this podcast and what this podcast can do for you. Now, you know, this week, this podcast is asking several things of you. And one of those things is each and every day, as we are going through all the great and wonderful themes to celebrate, we are celebrating cooling today. So that means go to your favorite cooling tower and take a picture in front of that and hashtag it to IWW23. Once again, that's hashtag IWW23. We get to see the entire Scaling Up Nation celebrate Industrial Water Week in front of the equipment that they are charged in treating. And boy, do we do a good job treating it. Because we treat it and because we treat it well, our customers are able to use that equipment to keep their vital industry going. And we all know water touches every aspect of our lives. And we, as industrial water treaters, are making sure that water is flowing properly, responsibly, cleanly, and we are using it for every drop that it's worth, making sure that we are treating it as such a vital resource, because we are using water at such an amazing rate, now more than we ever have throughout history. And the only reason we're able to do that and do that well is because of the people in the industrial water treatment industry. So hats off to all of you. And it's a big job. It's why we need an entire week to celebrate this holiday. And I hope that you are celebrating. This is a great industry. My call to action this week is for you to tell others about this industry, because we need to find great people to work in this industry. And we know that there's great people out there that have never heard of industrial water treatment. So we're hoping that all of you will help spread that message, not only this week, but each and every time you have an opportunity. Well, when we talk about cooling, normally we think about cooling towers. And cooling towers are something that the industrial water treatment community really can't agree on what to call them. So we had our friend Chris Nagle from EVAPCO come on this podcast actually several times, but most recently back in 2021. And we asked him, what are some things we need to know when we call a cooling tower a cooling tower?
When you think about cooling equipment, obviously there's dry coolers, which wouldn't need water treatment other than the closed loop. But when we think about other types that we would be thinking about from a water treatment standpoint, there's really four types. And if we think about them alphabetically, it would be adiabatic, which are gaining popularity, what I would call a closed circuit cooler, or you just referred to as a fluid cooler. You could use either term there. There's also evaporative condensers, and then there's the open cooling towers. And I like to say open cooling towers because it helps people understand that the water that's going through the tower is also going into the building and serving a function at a plate and frame heat exchanger or a chiller. So it's one big open loop that's rejecting the heat. When we talk about the closed circuit coolers or the evaporative condensers, they tend to have a coil, or they have a coil, and inside the coil is either water or a glycol water mixture that's going back to serve the process in the building. So the spray water for a cooler or fluid cooler is a much smaller volume, higher turnover. So that has implications for which biocides we might pick, how we might set up our feeding control. And then the other category is the evaporative condenser. And evaporative condensers look just like a cooler or a fluid cooler, the difference being on what's inside the coil. So instead of that water or water glycol mix, now we have a refrigerant, usually ammonia, but there are other refrigerants. So that can also be useful information for a water treatment professional, because compared to a fluid cooler or a closed circuit cooler, the skin temperature at the top of the coil, the condenser, tends to be much higher. So we want to think about that when we're selecting our inhibitors and our cycles of concentration and those kind of things.
If we're telling you exactly what it is that we're treating equipment-wise, then you're able to give us better information. So we're just communicating better.
Correct. And when we stop thinking of everything as a cooling tower, we can fine-tune our programs and think in terms of how the water is actually being used in that process. And it's really no different than if you have an open cooling tower at a hospital is maybe treated differently than an open cooling tower at a power plant or a refinery, right? So they're all variations, but it's important for the water treatment professional to think about, what is this equipment I'm actually treating? Let's get the right name so that we can communicate effectively and get the right program.
So there we are, Scaling Up Nation, trying to make sure that we can communicate with the manufacturers of the equipment that we are treating. We want to make sure we're using the proper language and we are all learning together. So thanks again to Chris Nagle and his team at EVAPCO. I want to give another shout out to EVAPCO. They have really doubled down into water treatment research. They have got the most amazing laboratory there, and they've got these little miniature cooling towers. They're really cute. And what they do is they put different products in there. They try different things to see what happens. And it's okay if they ruin a coil there. They can get another one. They can make another one. But they're doing that for us so they can get us that information so we don't have to experience that in the field. A lot of you might not know about all of the research work that EVAPCO does for the industrial water treater. So now you do. And Chris, I want to thank you and your team for making our job better with all the research that you are doing, and more importantly, sharing with all of us in the industrial water treatment community. Nation, Monday we celebrated pre-treatment. Tuesday we celebrated boilers. Today we are celebrating cooling. And of course, that means a brand new detective H2O story. But before we get to that, I again want to remind everybody to talk to whomever you can. Maybe even figure out how to go to your local college and teach a very brief class on industrial water treatment. We've been doing that for a while, and trust me, if you get to the right department head, you will be amazed at how entertaining they will be of that idea. I remember back when I was in 7th grade, a hydrologist came and spoke with us. And it was the first time that I kind of connected what my dad actually did, because I thought this hydrologist was really cool. And of course, my dad was just my dad. But I saw him doing some of the same things my dad was doing. And I really think that was one of the pivotal moments of my life where I really wanted to learn more about what it was that my dad did. That was because somebody invested in this industry and let students know that there was another option that they might not ever have heard of. So who knows? Maybe I would not have this podcast if it were not for that hydrologist. I don't remember his name. I just remember I thought it was really cool, all the slides he had and the test kit that he brought out that I immediately identified as something similar as my father's. So who knows? Maybe you can have an impact on that. So nation, here is the case of the dye job.
Welcome to Detective H2O, the case of the dye job. The misty rain slowly collided with the office windows of Herbert Henry Oxidane, P.I., CWT. As it coalesced and streamed down, the water detective's phone rang once, twice, 3 times. He answered. Detective H2O here, the best water treater this side of the Ohio, solving water problems drop by drop. What you got?
Mr. Oxidane, this is Frank from Food is Good Incorporated. You were down in our neighborhood about 2 years ago, working with the crew on a boiler foaming situation. Remember?
Oh, yes, Frank. I remember. Good coffee. We finally fingered the cause of the foaming to process contamination, hitching a ride back with the condensate from the processing department. You run a tight ship.
Yes, that's us. And the coffee's just as good. Grinding myself, you know. Well, we've got another scene over here going on. It's the cooling tower this time. Something's fishy because we can't get the conductivity up to where it should be. We put the squeeze on the blowdown valve, closed it completely. We even eyeballed the drain and there's no water coming out of that blowdown line. Zilch, none, zippo. It's got us all feeling jingle brain down here, Mr. Oxidane. Can you help?
I was looking for a good reason to blow out of here, Frank. I'll jumpstart my heap and be sliding your way faster than 2 shakes. Get that coffee brewing. With that, the water detective shimmied into his overcoat, donned his hat, grabbed his test kit, and headed out the door.
Good to see you, Mr. Oxidane. Hop on in. I'll take you to the culprit.
Detective H2O eyed the pickup truck and climbed in. I've been considering getting one of these, but my old jalopy in the parking lot would never forgive me. You might call me loyal.
Well, I can give you a jump start later if you need it.
Frank chuckled.
This up here is the cooling tower system. It's a big one, all right. Multiple cells with a common in-ground sump. Provides cooling water to all the surrounding buildings at Food is Good Incorporated. The conductivity is still way below control ranges. My fellas have recalibrated both the lab equipment and cooling tower conductivity controller 3 times each. They're thorough that way.
As they stopped beside the water system, Detective H2O got out and walked the perimeter of the cooling towers. He observed the blowdown line. There was an air gap between the blowdown piping and the drain, showing 0 flow. The manual blowdown valve was also closed completely. Next, he looked for signs of excessive splashing or drift, but found none. He checked the overflow line and found no flow. The water detective grabbed a water sample, and the conductivity was indeed well below the control range. Well, Frank, all the obvious culprits check out fine. Your conductivity is low. The blowdown is tight as a clam. I don't see any signs of bypassing the fill and splashing outside the basin, nor do I see excessive drift. The overflow line is bone dry. You are losing water somewhere, though. Let's do the math to see how big this mysterious loss is. Asking a few questions about the system size and operating conditions, Detective H2O pulled out his yellow notepad and a brick of a calculator and began crunching numbers. He soon looked up and said, "If my calculations are correct, and they usually are, you would normally be blowing down around 12 gallons per minute. At your current cycles, you are actually blowing down around 33 gallons per minute."
I'm no mathematician, but that's nearly 3 times the rate required.
Yes, when you consider that a typical garden hose flows around 12 to 13 gallons per minute, a 33 gallon per minute leak should stand out like a sore thumb. Either your basin has sprung a leak underground, or you're losing water out in the process of one of these buildings somewhere. Short of shutting down and draining the basins, let's start by following the cooling tower lines into the facilities it serves. We'll need to check every takeoff line, valve, etc.
That sounds like a great idea, Detective. We're at the height of production right now, so shutting down the cooling tower is not an option.
And for what you tell me, this low connectivity is a very recent and sudden phenomenon. Unless something catastrophic happened in the basin, I suspect water is being lost on the process side somewhere anyway.
Let's start with this building right here,
said Frank as he led the way. Frank and the detective spent the morning tracing down cooling water lines and talking to plant personnel looking for the source of the water loss. The detective sketched a process flow diagram as he went along. They covered 2 buildings thoroughly, but when it came to the third and last building, Frank said,
"Okay, here's the sticking point. Due to the proprietary nature of the production in this building, Building 6, we're not allowed in here. The facility manager is quite a stickler for protocol."
We've eliminated the other buildings rather thoroughly. It is most likely in this building. Can we at least talk to the boss?
Sure thing. I doubt we'll get anywhere with her. Well, one thing's for sure, if you don't ask for something, you're never going to get it.
Despite Detective H2O's best attempts to convince the facility manager to let him poke around looking for the water loss, she wouldn't budge an inch. The best they achieved was a promise to have her guys take a look themselves. Calling her on the horn later got the response that nothing was found.
Alrighty then. What now?
Okay, desperate times call for desperate measures. It's time to get this canary to sing one way or the other. Let's make this leak identify itself. Let's put red dye in the cooling tower water, if that's okay with you and your wastewater operations. We'll let the facility managers know, especially the Building 6 manager. Then we'll observe what drains we can for the dye.
I like it.
Putting the plan into action immediately, Frank, his team, and Detective H2O spent the afternoon looking for signs of the red dye. While none were found, strangely the conductivity in the cooling tower system began to climb in the early evening. The next morning, Detective H2O's phone rang 3 times. Detective H2O here, the best water treater this side of the Ohio, solving water problems drop by drop. What you got?
Mr. Oxidane, this is Frank. I wanted to let you know that the cooling tower conductivity held at set point all night long. It looks like we found the culprit.
Yes, it appears we did. Funny how making the water loss undeniable can do that. While we didn't catch the perpetrator red-handed, I'm sure someone is red-faced. In the underbelly and penthouses of the metropolis of Waterville, where the boilers percolate and cooling towers fog, there was one man who works tirelessly to end corrosion, stop scale, fight low-life microbes, and conserve water. That man is Detective H2O, best water treater this side of the Ohio, solving water problems drop by drop.
Down on Nation, as you know, I love working with James McDonald. And when he asked me to be a voice on one of his Detective H2O stories, I am just always so humbled by that. So James, thank you for including me. I love doing Water Week because we get to dust off all the Detective H2O stories and bring them back to life. And by the way, if you want to hear all of the Detective H2O stories. James McDonald has a website that houses all of that, and we're going to have that on our show notes page. Of course, you can bookmark, or what do you call when you put a mark in your podcast? I can't remember what that's called. But whatever you do to save an episode of a podcast, you can, of course, save these. I will tell you that this is a very fun and non-intimidating way that when you have new people that you are training, you can have them listen to these Detective H2O stories, and it kind of allows them to realize that there is some fun in this industry. When you're first starting out, there's so much to learn, and it is a little intimidating. And this is a way to learn with taking the intimidation away. So, James, thank you for coming up with this format. We all love it. Nation, I would love it if you would find your favorite cooling tower and hashtag it to IWW23. Tell anybody you can about this amazing job. If you're at AWT, come find me and celebrate Industrial Water Week with me at AWT. And if you are in this industry, I'm asking you, consider being a mentor. That's something that has helped me, and I went out and asked my mentors to be mentors. But maybe there's somebody that you know that you can call up and you can say, I would love to be your mentor. Maybe you don't feel like you've been in this industry long enough. Well, if that's the case, then ask somebody to be your mentor. That relationship is just amazing. And when you can call somebody that's outside of your day-to-day and ask them a question about something that you just saw that's brand new to you, it is amazing how people really learn from that experience, and people love to share their past experiences. One thing's for sure, I love to celebrate Industrial Water Week with you, and we're going to have a brand new episode tomorrow for Wastewater Thursday. Happy Industrial Water Week, everybody.